In this video, we'll talk about the main elements that either generate or transfer heat in order to compensate those heats by providing cooling to an AC unit. It is an introductory cooling assessment 101. So without further ado, let's get to it. We will start with heat transmission through exterior wall, which depend on local peak summer temperature, area of wall construction, and hence its U value. U value is thermal transmittance. It is simply the rate of heat transfer across a substance due to temperature difference on both sides of that substance. It measures how effective this substance as an insulator. An exterior door can be treated similarly to an exterior wall and have the same conditions. Then there is heat through glazing from outside, whether it is a window in a wall or a skylight in roof, which depend on peak summer temperature, glazing area, U value and shading coefficient, color, reflectivity, and whether single, double, or triple glazing, etc. Shading coefficient, we mentioned before, is the amount of heat transferred relative to clear glass, which has shading coefficient of 100%. So a shading coefficient of 0.8 means 80% of sun rays passes through glass. For glazing, in addition to transmission heat that wall has, it has also radiant heat, which is the invisible sun rays that passes through glass and air without heating them. It must strike a solid non-clear object for that object to absorb and transfer heat to the surrounding air. We have also heat transmitted through combination of roof and ceiling, which subject to peak summer temperature, roof area, roof construction, thus its U value. Here, a portion of the roof heat transmission will go to the room by passing through the false ceiling, while a portion will go directly to AC unit, since we have an open retained air false ceiling void, which means the retained air goes through the void area above false ceiling that acts as a plenum for retained air. If you don't have false ceiling, then it is considered that all the heat transmitted from the roof is going to the room. Then we have heat transmission through partition wall, which is an internal wall that lays between conditioned and unconditioned spaces. Here we need to know the temperature of unconditioned space, partition wall area, and partition wall U value. Before we continue, I would like to remind you to subscribe today, hit the notification bell, and give a thumb up. Also, cooling of outdoor air that is mixed with the retained air can be a significant portion of the overall cooling load and depends on its temperature and humidity conditions as well as its amount. It's recommended that outdoor air be more than exhausted air from toilets, kitchens, etc. by 10 to 15%, so the space is in a positive pressure and therefore would not be any infiltration and thus no infiltration load. We have also internal loads such as from people, equipment, and lights. We'll start with the people loads. The total heat dissipation loads from people depends on number of people activity. For resting or light office work, these heat dissipation loads are small, while for heavy factory works or athletics activities, they are high. The values for these heat dissipation loads can be taken from any rated international standards. Another internal loads are equipment inside space that generate heat, such as computers, TVs, kitchen appliances, etc. The values of these heat dissipation loads we get it from equipment catalog or from an international standards. There are also light loads, which depend on light wattage, type of light fixture, whether incandescent, fluorescent, LED, etc. Well, when we have light fixtures installed in the false ceiling, portion of the light heat, usually between 30 to 50%, goes to the ceiling plenum void and does not directly affect the room, while the remaining percentage do. If there is no false ceiling all the light load would be on the room. The thermal data for the light fixture we can get from either catalogs of the light fixture or from an international standard. The load from floor is negligible in cooling load assessment because earth temperature is usually close to or a bit cooler than indoor temperature, and therefore heat transfer through floor is insignificant. By the way, this is not the situation in heating load, which will have dedicated videos in near future talking about heating load assessment. Other loads which could be marginal but worth mentioning are heat dissipation from fan motor of AC units and heat transfer through duct to cooled air, which are usually much smaller than other loads. To wrap this up, the calculations of cooling load for building can be a very involved task and are influenced by many elements. Needs to look into many catalogs and tables from international standards as mentioned earlier. However, for many years now, these calculations are done through sophisticated softwares that have built-in data library for walls, glazing, roof and ceiling, partitions, people, lights, equipment, etc. that you simply select from a list and it will provide its thermal data such as U values, Shelly coefficient, etc. These softwares greatly cut the time needed to do calculations and are more accurate. I hope you see value in this video. If so, subscribe, give a thumb up, slap on the notification bell, share with your friends, and tell me what you think by noting down at the comment below. See you later in future videos.